Alright, so we're going to continue working with solving exponential and log functions. Now we're going to look at what I'm calling simple log functions, right? And I'm calling them simple log functions because these are ones that you shouldn't need to do any advanced calculation for. You should just be able to do maybe with a simple calculator or just kind of knowing some of the exponents as we go. Right? So if I'm taking a look at this problem and it's saying log base 125 of 5 equals x, what is the value of x? Okay, so there are a lot of situations where we want to be able to convert between log form and exponential form because some problems it will be easier to solve in log form. Other problems will be easier to solve in exponential form. And so we want to, if I'm looking at this problem and I'm saying, you know what, I don't really know how to solve this one in log form, maybe if I switch to exponential, it'll be easier to solve. So we're going to do that with this problem. And if you remember from the log video, we said this number right here is the base when I switch to exponential form. The output is the exponent, and this 5 would be like the answer to the exponential problem. So this is going to be rewritten in exponential form as 125 to the x is equal to 5, right? And so I'm going to turn this into a base of 5, okay? So I need to figure out how do I turn 125 into a base of 5, and I'm going to use this 1-to-1 property. And so 125 is 5 to the third power, okay? And this, remember, 5 is really just 5 to the first, right? So if I'm trying to do a 1-to-1, I need base, the same base, and I need exponents on each of them. So I'm going to say in this case, this is x, 3x is equal to 1, and that means that x has to be 1 over 3, right? So this is something where until we get into some more advanced log properties and something called the change of base formula, we're not going to be able to do this log base 125 of 5, but we can turn it into exponential form and solve it that way. And we can say in this case x to the 1/3, which is another way of saying the cube root, if I take the cube root of 125, okay? So let's try the next one, right? So same thing, I'm looking at this, I'm like, how would I figure out what the base of a log is, right? So we're going to turn this into exponential form, and if I did this, remember, base, exponent, output, I'm going to say this is x to the 5th is equal to 32, right? And again, I can rewrite 32 as something that has a base, or has an exponent of 5. In this case, this would turn into x to the 5th and 2 to the 5th. And because the exponents are the same, I can say that x has got to be equal to 2. So this is just going to be at x equals 2. Okay, and that would be my final answer. So the only way that this log is going to work and be a true equality is if this was a log base 2. Okay, so my last one's actually the easiest of them here. I'm going to rewrite this one and say log base 3 of x is equal to 4. Well, this is the base. This is the exponent. So I'm going to say 3 to the 4th power equals x, and 3 to the 4th power is just 81, right? So again, this kind of looks mysterious in log form, but when I turn it into exponential form, it's something that's a little bit easier to solve, okay? So now we're going to kind of just continue with this trend of saying, okay, I'm seeing this, all right, you want me to solve log base 3 of x minus 5. How do I do that? Well, if it doesn't make a whole lot of sense in log form, let's switch forms. So we're going to say, remember, x minus 5 is going to be the output, and this is 3 to the 3rd power. So it's going to say x minus 5 is equal to 3 to the 3rd power. Well, 3 to the 3rd power is 27, right? And now this is actually a really easy problem to solve. If I add 5 to both sides, I find out that x has got to be equal to 32. And that's all I had to do for that one, right? So again, it looks very mysterious in log form, but when I rewrite it in exponential form, it's actually a very straightforward problem, okay? And so these other ones, I'm just kind of throwing a little bit of extra into the problem just to highlight the fact that you can only convert between exponential form and log form if the log is isolated. And what that means is that the only thing that's floating around on that side of the equation is the log and the thing that you're taking the log of, right? So this 5 is outside of the log, this negative 10 is outside of the log, so we're going to need to get rid of those. And so in this case, I'm doing 5 times the log, so to get rid of that, I'm going to divide both sides by 5, okay? And then I'm going to say this is now just the log base 4 of 2x plus 1, and now it equals 3. Okay, so now I'm going to look at this and say, now it really looks like the one right above it, and I can do a conversion, 4 to the 3rd power, right? So 2x plus 1 would be equal to 4 to the 3rd power. Well, 4 to the 3rd power is 4 times 4 times 4, which is 64, right? So I'm going to bring this up here, and we're going to say that 2x plus 1 has to be equal to 64. That means that 2x has to be equal to 63. And if I divide both sides by 2, I'm just going to leave this as 63 over 2, right? We don't need to simplify that, okay? So my answer here, not a nice number, 63 over 2, but that's the answer, okay? It's okay to have, right? So moving down to the next one, we got to be careful. This has got a plus sign before the log now, so this is actually negative 10 being added to the log. So to get rid of a negative 10, I'm going to add 10 to both sides, okay? And now it says log, okay, base 12 of 3x minus 11 is equal to 0. And again, now that the log is isolated, I can convert into exponential form. This is 12 to the 0 power. So 12 to the 0 power equals 3x minus 11. Well, 12 to the 0, anything to the 0, is just 1. Right? So this says now 3x minus 11 equals 1. And so that means in this case, if you add the 11 over and divide, that x has to be equal to 4. Right? So again, looks very cryptic and almost a little bit complex and intimidating when it's in this form, but when we turn it into exponential form, it's a very straightforward problem to solve, okay? So just don't be intimidated by them. Isolate your log, switch to exponential form, and most of the time they will be solvable, okay? So we're going to end off, this is just kind of a side note problem before we end off with some, what I'm going to call, again, slightly more advanced versions of what we just saw. If you see something like this, it's entirely possible as you're going through and solving or evaluating expressions that you might be asked to take the log of something. And so the question is, how do I handle these things? And it's just the same as anything else. Start on the inside, work your way out, right? So I'm just going to isolate this and say, can I do log base 2 of 4? Yes, I can. 2 to what power gives me 4? The answer is just 2, right? This whole expression, it just says is 2. 2 to the second power gives me 4. So now this says log base 4 of 2, and the question is now, how do I get, again, something like this. How do I get 4 to what power is going to give me 2? So I'm going to rewrite this in exponential. 4 to the x is equal to 2. I can use my exponential property and say this is, or my 1-to-1 property and say this is 2 squared, okay, equals 2 to the first. And it's pretty straightforward to see now that if 2x has to be equal to 1, that the only way that this is going to come out is going to be as if x is equal to 1/2. Okay? So the final answer to this problem, when I simplify the log base 2 of 4, and then I simplify the resulting log base 4 of 2, I find out that it's really the final answer is 1/2. Okay? So there's those strange kind of log to a log problems that you might see. Okay? And so this is where we're going to end up. We're going to look at some problems that, now that we know how to solve using the 1-to-1 property, now that we know how to convert to logs when necessary, we're just going to look at some strange cases and some different cases, okay? So in this first problem here, they're asking us to find x, but we want to use that 1-to-1 property. Okay? We can't do that if the 6 is floating out here. So again, this is just to highlight, if you're going to do the 1-to-1 property, if you're going to do log conversions, you want to isolate the exponential or the log. So I'm going to subtract 6 on both sides. This is going to become 3 to the x minus 2 equals 27. And then I can turn 27, okay, into 3 to the third. Okay? And then I can just say, now that the bases are the same, that x minus 2 has to be equal to 3, and so x has to be 5, right? And that's my answer here, okay? So it's just kind of a similar concept, right? Here's my my log problem again. I can't do a conversion until the log is by itself, so if I divide both sides by 5, I find out that the log base 3 of 3x squared is equal to, if I divide both sides by 5, it's 3, okay? So now this is going to say 3 to the third power. Now that my log is by itself, I can do that conversion. 3 to the third power equals 3x squared. All right, now that I'm going to look at this and say, okay, this is 27, and I can just solve from here. Okay? Divide both sides by 3, I get a 9. And if I square root both sides, I find out that x is equal to plus and minus 3. So there's kind of a strange case where I got 2 answers that could work. Okay? So again, moving down, it looks like in this third problem over here that it's, again, just isolate the log. But when I'm doing this one, I actually have to make sure I do my order of operations. I'm going to subtract the 10 first. So now it just says 2 log base 2 of x squared is equal to 16. Then I can divide by the 2, right? Divide both sides by 2. And now it says log base 2 of x squared equals 8. Okay, let me move my last problem down. Okay, and now I can do my log conversion. And so here's where the problem gets a little bit strange. 2 to the 8th is equal to x squared. So you could go to your calculator and try to figure out what 2 to the 8th is and then square root both sides. And that's entirely okay. But 2 to the 8th starts to get to be really big. And so when you're handling these really big exponents, it's like, well, I don't really want to do that. So instead what I'm going to do is I'm going to say, if I can write this in a way, okay, that allows me to have the same exponent on both sides, that 2 on both sides, here's what I can do. I can say this is 2 to the 4th squared. So I'm using a property of exponents. Instead of writing 8, I'm writing 4 times 2 is equal to x squared. Okay? And so what I can do with this now is say, oh, well, now x just has to be 2 to the 4th power. And that's a little bit more reasonable to solve. 2 to the 4th power is just 16. So I can say, in this case, x has to be equal to 16. Okay? And so that's a slightly more reasonable way without using a calculator to figure out what 2 to the 8th is in order to get that answer, right? So that's just kind of another strategy you can use. Okay, here's your last problem. In this problem, I'm kind of stuck. I can do a log conversion right away because log is the only thing on the left-hand side. It's isolated. That's good. But there's no base here. And it's kind of like, oh, what do we do now? There's no base. Okay, so here's the strange thing with this one. So you know how we have problems like if I just write x, we assume that there's a 1 sitting out in front of the x. We also assume that there's an exponent of 1 floating out here. Whenever I write log, we make an assumption as well. If I don't write log, we assume that the base is 10. And the reason for that is that our entire number system is base 10 numbers, right? We use decimals where we divide and multiply by 10 to change, decimal places. So it's the same kind of concept. If we don't write any base for a log problem, we assume the base is 10. So this really just says that 3x plus 1 is equal to 10 squared, right? And then I can go through and solve. 3x has to be equal to, well, that's 10 squared is 99. I'm sorry, 100 minus 1 is 99. And I can divide both sides by 3 and find out that x has got to be equal to 33, right? So again, just kind of a strange little twist to a log problem. If they don't write a base, we assume the base is 10.